Welcome to the AI History Channel. In today's episode, we tell you the story of the bomb Japan almost built. In May of 1945, a German submarine surfaced in the North Atlantic and surrendered to the American Navy. In its cargo hold were 10 lead-lined containers holding 560 kilograms of uranium oxide. They were addressed to Tokyo. Japan was building an atomic bomb. The question is not whether they tried. It is what would have had to change for them to succeed. This is not alternate history yet. This part actually happened. In the autumn of 1940, Japanese Army studies concluded that building an atomic bomb was feasible. In 1941, the Japanese government authorized a bomb project. Its code name was NIGO. It was housed at Riken, the Institute of Physical and Chemical Research in Tokyo. More than 100 researchers worked there under the physicist Yoshio Nishina. Nishina was not a second-rate scientist. He had studied in Copenhagen under Niels Bohr, and he was known as the father of nuclear physics in Japan. After the war, the Manhattan Project's own intelligence group reported that Japan's nuclear physicists were as capable as those of any other nation. The Navy ran a second, entirely separate program. It was called EFGO, EF for fission. It was led by Bunsaku Arakatsu at Kyoto Imperial University, a physicist who had studied at the Cavendish Laboratory in Cambridge under Ernest Rutherford. His team included Hideki Yukawa, who 4 years later would become the first Japanese physicist to win a Nobel Prize. So Japan had two programs, and two of the finest physicists in Asia. And the two programs barely spoke to each other. The Imperial Army and the Imperial Navy despised each other. Their rivalry was not professional disagreement. It was institutional and total. But the rivalry is not what killed the Japanese bomb. Three other things did. The first was uranium. Japan had almost none. It scraped ore from mines in Korea and Burma and never came anywhere close to enough. Historians later concluded that the same shortage of high-quality uranium that had stopped the German program also stopped the Japanese one. And that is exactly what the submarine was carrying: 560 kilograms of uranium oxide. It contained roughly 3.5 kilograms of usable uranium-235, about 1/5 of what a single bomb required, 1/5 of one bomb on one submarine, which arrived too late and surrendered to the wrong side. The second problem was electricity. Separating uranium isotopes consumed staggering amounts of power. The American enrichment plant at Oak Ridge drew more electricity than some entire American states. By 1944, Japan was rationing electrical power just to keep its aircraft factories running. The third problem was industrial capacity. And this is the one people consistently underestimate. The Manhattan Project cost around $2 billion and employed roughly 130,000 people across an entire continent. The entire Japanese naval program, meanwhile, managed to obtain about 20 grams of heavy water per month. Not kilograms. Then in April 1945, an American bombing raid burned down the building at Riken that housed the isotope separation work. The Japanese atomic program did not so much fail as simply evaporate. So here is where the documented history stops and the counterfactual begins. Bad alternate history changes one thing and declares victory. Good alternate history follows the chain. For Japan to drop an atomic bomb on an American city, at least 4 things have to change. Japan secures a uranium supply before the war, most plausibly to a formal Axis materials pipeline beginning in 1940, not a single desperate submarine in 1945. The Army and Navy programs merged in 1941 under a single command, the way the Americans forced their own rival factions into one project. Japan builds its separation plant far beyond the range of American bombers. The obvious candidate is deep inside occupied Manchuria. And 4, the one that breaks almost every version of this scenario. Japan needs a way to actually deliver it. Even granting all 4 changes, the earliest realistic Japanese device does not arrive until late 1946. But by late 1946, in our actual timeline, the war has already been over for more than a year. So the scenario demands one more change, and it is enormous. Japan does not attack Pearl Harbor in 1941. Without Pearl Harbor, America enters the Pacific War later or on entirely different terms, and Japan buys the years of industrial peace that it needs. Notice what has just happened. To get Japan one single bomb, we have had to rewrite the entire war. Now, assume all of it. It is 1947. Japan has a working device. Now it has to reach America. The American bombs were carried by the B-29, an aircraft with a 10-ton payload and a combat range of over 5,000 kilometers. Japan had nothing comparable. Its heavy bombers were built for shorter ranges and far lighter loads. What Japan did have was strange, ambitious, and completely real. The I-400 class submarine. It was the largest submarine anyone built until the nuclear age. It carried 3 folding wing float planes inside a watertight hangar on its deck. It was designed to surface off an enemy coastline, launch its aircraft from a catapult, and disappear beneath the water again. In our timeline, it was built to strike the Panama Canal. The war ended before the mission ever flew. This is the only plausible Japanese delivery system for a nuclear weapon. And it is a terrible one. The float plane it carried had a maximum bomb load of roughly 800 kilograms. The weapon dropped on Hiroshima weighed more than 4,000. So Japan needs not merely a bomb, but a miniaturized bomb. A problem the Americans, with vastly greater resources, had not yet solved themselves in 1945. Every path through this scenario ends at the same wall. And the wall is not physics. It is engineering, logistics, and industry. And that is the real lesson buried inside this counterfactual. The atomic bomb was never primarily a physics problem. By 1941, the underlying physics was published, and several nations understood it perfectly well. It was a problem of national industrial capacity, of electricity, of ore, of 100,000 workers in a country that nobody was bombing. Japan did not lose the race to build the bomb because its scientists were inferior. They were not. It lost because by 1945, it could no longer reliably produce aviation fuel, let alone enriched uranium. The question was never whether Japan could imagine the bomb. It was whether any nation already fighting for survival on its own soil could ever have built one.